Hello friends, welcome to Quickfire Numerical Solving Sessions for GATE 2021. We'll do a numerical based upon frequency modulation today, and here it goes. This is a typical question where the frequency modulated wave has a frequency sensitivity to be given as 15 kilohertz per volt. So this is KF is frequency sensitivity, and the message signal XT is this. And we know from this XT we can find AM, which is the maximum amplitude of the wave of the message signal, and this is omega m. So this omega m, this is omega t from the generalized equation. And once we know this, we need to determine delta f. Please understand, delta f is maximum frequency deviation. So when you study frequency modulation, you know what frequency deviation is, and we need to find out maximum frequency deviation in a frequency modulated wave. And MF is the modulation index, and bandwidth is the third thing that needs to be found out. So these are the key points in this numerical, so you should be able to comprehend what's given. And secondly, there are some key formulas also. Omega m could be found out from this equation from right here. From omega m, of course, we can find Fm also. And then the formula for maximum frequency deviation is Kf into Am. So Kf is given in the question, which is the frequency sensitivity multiplied by the amplitude, which is right here. And then the formula for modulation index is delta f upon Fm. So this is a very popular formula where modulation index is the maximum frequency deviation upon the Fm of the wave, the maximum frequency component of the modulated wave of the Fm. Fm can be found from the message signal. And then to find bandwidth, which is the third thing that we need to find, we could find it using two methods, using Carlson's method and significant sideband bandwidth method. The Carlson's method says that the bandwidth is twice of Fm plus delta f. We know what Fm is and what delta f is, and significant sideband is 2 into n into Fm, where n is an integer taken out of the modulation index. Let us say our modulation index is 8.2, so we'll take the integer value out of this number, which is 8. So let's proceed, and from this we know that omega m is 10 raised to power 4 pi radian per second. We could find Fm, which is 5 kilohertz. So first thing is to find Fm, which is 5 kilohertz in this case, and we know that the maximum frequency deviation is 15 into 5. Right from here, this is Kf and this is Am. Am is 5, by the way, from here, right? And this Fm will be used in this step where we find the modulation index. Modulation index is delta f, which is 75, calculated right here, divided by 5. Now this 5 is this 5 kilohertz, because modulation index is the unitless quantity. Then we have bandwidth. So we have two methods of finding bandwidth. This one is Carlson's method, so we have 2 into Fm plus delta f, which results me 160 kilohertz bandwidth. And the other method is 2 into 15. Now modulation index is 15 and 5 is the Fm, so we get 150 kilohertz. So there is not much of a deviation here. But what happens if Fm is doubled? If Fm is doubled, this thing will be 10 kilohertz. Now this could be 10 from the fact that this would change. In the question, if this changes, the Fm also changes. Now let us say Fm is doubled. So what will happen? Let's see. Will there be a change in delta F? No, because delta F depends upon KF, which is still 15 kilohertz, and AM, which is still 5, the maximum amplitude. So there is no change. Will there be a change in modulation index? Yes, because now modulation index will become 75 upon 10, because FM is 10. So this will become 7.5. This is halved. So by changing FM to double, we get the modulation index to be halved. And what about bandwidths? Bandwidths will also be changed. Carson's bandwidth is 2 into 10 plus 75, which will give me 170 kilohertz, and the bandwidth calculated from the significant sidebands is 2 into n into FM. Now n is 7.5, but we'll take 7, the integer, so it is 140. So this gap has become more when we increase the frequency in our message signal. So this is how a typical numerical will look like, and I hope you liked this video. If you did, give it a thumbs up, consider subscribing. I'll make more such videos, quick fire videos for gate preparations every day. Till then, take care. Bye bye.